Problem number 26. A sled loaded with the children starts from rest and slides down a snowy 25 degrees with respect to horizontal incline, traveling 85 meters in 17 seconds. Ignore high resistance. What is the coefficient of kinetic friction between the sled and the slope? If we know what is acceleration, we can find what is coefficient of friction, because we have this equation ma equal horizontal part of gravity force, which is mg sine alpha, minus force of friction, which is mu, multiplied by normal force, which is mg cosine alpha. So from here we can find what is acceleration. That's a g sine alpha minus mu cosine alpha. So from this formula we can find what is coefficient of friction if we know what is acceleration. Alpha is done, 25 degrees. But acceleration we can find from this data. We have distance, we have time, and we have kinematic formula that distance equal 1/2 a t square, and we can find that acceleration equal 2d over t square. All numbers are done, and we can count what is acceleration, put in this formula, and find what is the coefficient of friction. That will be 0.4. Problem number 27. A space station consists of two living modules attached to a central hub on opposite sides of the hub by long corridors of equal length. Each living module contains n astronauts with the equal mass. The mass of a space station is negligible compared to the mass of the astronauts, and the size of the central hub and living modules is negligible compared to the length of the corridors. At the beginning of the day, space station is rotating so that the astronauts feel as if they are in a gravitational field of a strength g. Two astronauts, one from each modulus, climb into the central hub, and the remaining astronauts now feel a gravitational field of strength g prime. What is the ratio of g prime over g in terms of n? To solve this problem, we need to use two conclusions. First is that we know that the gravitational field equal r omega square. So it means that r is the same in both cases. It means that g prime over g equal omega prime square over omega square. That's the first one. Second one, we have angular momentum conservation due to absence of external forces. It means that we can use in the form of I omega equal I prime omega prime. So to count I, we use a formula total mass to n m multiplied by r square. and I prime equal to n minus 1 m r square. So using this this equation, we can conclude that I prime over I equal I'm sorry, we can write down that omega prime over omega equal n over n minus 1. And finally, using this equation, we can find that it's equal to n over n minus 1 square. If we check options, we see that none of these options are our solution. It means that the correct answer is E, none of them.